So let's now do step 1 and step 2 of the little design spreadsheet for air terminals. Step 1 is to do an energy analysis and then plug in the numbers that you get from it for step 1 and step 2. So let's see how we can do that. Let me go to a Revit file. Here's a little single building. It's a very small, very simple one. And if we go to the Analyze tab, you'll see Energy Optimization. And you should see a little box that says Create Energy Model. You want to do that. So I'm going to create the energy model. Yes, I'm going to do it. And there it is. That's our energy model. It kind of tells you the space. There's a ceiling below and a thing above, and it's kind of taking up that whole space. Once we've got an energy model, again under Analyze, we're going to do a systems analysis. Now note, you need to make sure your location is right. I've got this one in Boston right now. But before you do any of this, do be sure that the modeler has put the location where you want it to be. And we're not going to do the zoning stuff right now. Okay, so here we go. System analysis, bank, and I want the loads and sizing. That's the most important one for me right now. I'm going to calculate for a little while, so I have to kind of be patient with it. It might take a minute or two. And when it's done the reports, we'll be able to see it. You can see it's still calculating, still calculating. Big buildings take more. We'll be patient. What we can do is look and see what is going to come up. We're going to get a number that'll tell us the airflow per floor area. So if I have 1,000 square foot house, this one, if it was one, I'd need 1,000 CFM. Cubic feet per minute of air. And it's per square feet, and you'll see why eventually. Okay, and then they're going to get a peak load of heating and a peak load of cooling. And it gives it to us that in BTU per hour. So a BTU per hour is, well, there's 12,000 of those in every ton. And some air handlers are given in BTU per hour, and some are given in tons. So we're going to just transfer that down here, and we'll just base it on the highest one. See if we've got this yet. Yes, we do. So it tells us a little bit about the conditions. And here are the engineering checks that we need. And we need the airflow per floor area. So this is coming out 1.25. It's that big, long number there. 1.251325. 1.25 325. See if I've got that right. 1.251 325. So that tells me I need 1.25133 cubic feet per minute for every square foot of floor space. Look at my peak heating load. Down here, the red one, 11380. 11380. and a peak cooling load of 11511. And so that's your step 1, and step 2 comes out automatically. You leave it down here. It finds the biggest one. You're interested, that's the max formula, and it calculates the tons by dividing by 12,000, ever that max one was. So that's your first step. And you can do that for all of the samples. There are a number of samples provided here. I go open up. There's 1 space, 3 spaces, and a big box for you to work on. So you can do steps 1 and step 2 just right off the bat and get those going.